Okay, so the lab we're going to be doing today is pretty straightforward. It's very much like the one you did in Science 10, okay, where you just had the motorized carts that were going down the hallway and you were measuring their position every 5 seconds or whatever it was, okay? Except that we're not going to be bothered by such a tedious procedure. Okay? We're just going to give these electronic carts here, we're just going to give them a little push on the various tracks that we have, okay? And these carts, okay, are Bluetooth enabled, and they will transmit their position and time and velocity and acceleration and a whole bunch of other things we don't need. Just position and time is all we need. But they'll transmit all of that data via Bluetooth to the app on your phone. Okay, and then you'll be able to put that into Google Sheets and automatically graph it. Okay, it'll take us a lot less time because we won't have to be measuring everything by hand and all of that kind of stuff. Plus, it gives way better data and records data as many times as you want per second. Okay, usually we have them set at 10 or 20 hertz, which means they're sending that data to your phone 20 times per second. Okay, so you get a lot of data points and a lot of really good, reliable data that you didn't get with the motorized cart with someone kicking it, trying to keep it straight as it went down the hallway. Okay, so these will give us way better, more accurate data that's easier to use. Okay, one thing to be mindful about with these, they do all this really cool stuff. As a result, they have little processors, computer chips, whatever inside, and are not cheap. And by not cheap, I mean they're like several $100s each. So please be very, very careful with them. Should they be dropped on the floor from, even this high, that could be the end of them, right? So just be careful with them. And also be aware that they will try to scare you. Okay, we use these for see, it scared you. We use these for momentum experiments in physics 30, so they have this little propulsion system that's just a spring-loaded thing. Okay, if you tap this little black button right here, it will shoot out. Okay, it's used to be put it against a wall or another cart and just push off. Okay, just be aware that that might happen. You might just want to set it off right away and then not have to worry about it doing that and scaring you later. Okay, especially if you're holding it when it happens and you drop it. Okay, so just be aware that little black button will cause that to happen if it's loaded. Okay, all right. It does have directionality, so you actually do have to make it go the right way, or it will tell you it's moving backwards. Okay, so there's a little X, Y, and Z diagram on it here. Okay, so this is the front end. This is the back end. Okay, so just make sure you've got it facing the right way when you get it running. Otherwise, it'll tell you it's moving backwards because from its point of view, it is. Okay, and we don't need that. All right. Questions on the car itself? It's going to be pretty straightforward. We'll be using it on these tracks over here. Okay, either the metal tracks or the wooden tracks. We've grooved the wooden tracks as well, so they're set up, okay, to match the wheel width and keep them on the track. Okay, so the tracks will just be set on the floor, right, and these will just run along very easily on those tracks. Okay, don't try and run it directly on the floor. They don't record data as well if they're not on the track. All right. So our problem today, okay, how can the speeds of two different toy carts be determined? So basically this is just an exercise to review the uses and interpretation of a position versus time graph. So we're going to run two cart, well actually we're just going to run one cart, but we're going to give it two different pushes, okay, on the track. We're going to graph those two trials on a position versus time graph, do a little bit of analysis with that, calculate the velocity of both carts, okay, and come to a conclusion. So it's a pretty straightforward lab, okay, and should be all pretty much review for you guys. All right, so our variables here, manipulated, responding, and controlled. In your lab reports, okay, you can see there it says identify and explain your variables. Okay, so I will want a manipulated variable, identified, and explained. Okay, so in that explanation, I want to know why you think this is the manipulated variable, okay, and how it's being manipulated. Right? For your responding variable, and for this experiment, there's only one. There can obviously be more than one responding variable, but for this experiment, there's only one. Okay, again, explain how it is responding, okay, to the manipulated variable. For your controlled variables, I want 3 controlled variables. Okay, those are the things that stay the same throughout. Okay, and in the explanation for each one, how it's being controlled, how it would affect the experiment if it were not controlled. Okay. So basically in this experiment, anything that could affect the speed or position of the cart, okay, is got to be controlled. All right? Everybody with me there? So, give you a little bit of help here with the identification because it's been a little while. Usually what goes on your graph is your manipulated and responding variable. Okay? And your manipulated variable always goes on which axis? Well, your manipulated variable always goes on the x-axis because you're comparing the effect of it changing on your responding variable, which goes on the y. Okay? On a position versus time graph, I think you know which one goes where, and that should help you figure out which one's manipulated and which one is responding. Okay? Now here's the problem most people have once they figure that part out. I'm not manipulating time, Mr. Coder. Well, yes you are, in the only way that we can manipulate time. We're not making it flow faster or slower or backwards or sideways, okay? We are simply allowing it to elapse, and we are choosing essentially how much of it elapses, okay? The longer the cart is allowed to travel, the farther it will go. It's as simple as that, okay? That's how we're manipulating time, okay? We're manipulating time by essentially determining how long the experiment will run for. That determines everything else. The longer I let the experiment run, the more other things will change, okay? So that's how we manipulate time, whenever time is a manipulated variable, okay? Unless you get into quantum physics and you're actually manipulating time, which would be incredibly cool. Let me know if that ever happens, okay? All right, questions there? Right, so identify manipulated variable, explain, which we kind of already did. Responding variable, and explain. Okay, 3 controlled variables. Anything that can affect the speed of the cart, okay, or the position of the cart needs to be controlled. It's one of the reasons why we're putting these ramps on the floor. Because, you know, the floor is fairly flat. Fair. Okay, and so are the ramps. Fair. Okay? Things to think about there. Okay, for our hypothesis, okay? In our hypothesis, we want to generate a hypothesis about how position versus time data for a cart moving at a constant speed can be used to calculate speed, okay? What 3 words go in all hypotheses? If, and then, okay? The if part is your premise, okay? So in the if part of your experiment, okay, I would say it would probably be a good idea to define what velocity is. Okay, we talked about that. Okay, velocity is, you know, well, you can tell me because I'm not going to give it to you. Okay, kind of define velocity, describe how velocity relates to this and to that in the if part. So if velocity is blah blah blah. Okay, the and part of the hypothesis describes the experiment. Okay, not in detail, just very briefly. Okay, it could be as simple as a cart is allowed to travel at a constant velocity along a track while its position and time are measured. That's all we're doing. Okay, that's a brief description of the experiment. Okay. Okay. The then part needs to tell me how you're going to calculate velocity from your position versus time graph. Here's the important part about that. You will not be using that, okay? So the then part of your hypothesis should not say, take the total displacement and divide it by the total time. I don't need a position versus time graph to find velocity that way. I want in your then part for you to tell me how from your graph you will calculate it. There's a certain part of your graph, specifically the line on it, that will allow you to calculate velocity. That's a pretty big juicy hint. Okay, everybody with me there? Okay, so the then part needs to talk about how from your graph / best fit line, okay, you'll calculate velocity. Okay, so your design is worth 5 marks, your hypothesis, 5 marks. Okay, it needs to be in that format. Okay, giving you some pretty big hints on how to get those set up. Okay, so for the procedure, procedure is going to be pretty straightforward. You're going to take one of these carts and you're going to pair it up with your phone, through the Sparkvue app. Did I tell you guys to download the Sparkvue app? Okay, with my period 4 class I told. Okay, so you're going to need this app on your phone. It's called Sparkvue. Okay, it is the app that will talk to these carts. Okay, you just need the free version. I think there's still a paid version on there, but you don't need it. Okay, you just need the free version. So you just need to have that installed. Okay, at least one member of your group needs to have it on their phone. Okay, it'll only talk to one phone at a time. Okay, so what we're going to be doing is we're going to put the cart on one of these tracks. Okay, but you're going to do this on the floor. I just got it on the desk so everybody can see it. Okay, do not put it on the desk. First off, the desks aren't level. Some of them are bent. Okay, you just wobble like crazy on there. Okay, so you're going to have your cart. Okay, on there, you're going to have somebody operating the app. Okay, it'll have a start and a stop button. I'll walk through how the app works here in a minute. Okay, and it's going to be very simple. All right, they're going to kind of give you a countdown like 3, 2, 1, go. Okay, if you're the person who's managing the cart and the track, all you're going to do when they say go is on the first trial, give it a light push. They're essentially pretty friction free, so they should, once it accelerates and you let it go, it should travel at a constant velocity once you're not pushing it anymore, and you should get some decent data on that. On the second time, push it a little bit harder. Okay, not a lot harder, it doesn't need to go flying. Okay, just a little bit harder so you get a slightly different line on the second trial slide. Okay, so one slow, one fast. You got your data. Okay, so that shouldn't take long at all. Then all you're going to do is from the app, you can share the data with your group mates. It just emails it to them or sends it to them through Google Drive. Okay, and then you can access it and insert the graphs and pictures and everything you need. Okay. All right. Okay, when we get to the analysis, okay, so the analysis is pretty straightforward. Okay, you're going to use the Google Sheets software to plot a position versus time graph that has both carts plotted on it. Okay, and I'll show you how to do that once we have our data. Okay, and then using y equals mx plus b, determine the velocity of both cars. Okay, so some part of that equation represents the velocity of both cars. Okay, you need to do that and show me that calculation for each car. That's all there is to the analysis. Okay, is showing me your calculation of velocity for each car. And all that's going to entail, guys, is really manipulating this equation to solve for whatever part of this equation is velocity. You don't even have to plug in any numbers. Okay, just do it. Everybody follow there. All right, for your conclusion, copy and paste your hypothesis. Okay, that's all you'll have to do there, copy and paste it, and then explain using your data and your analysis whether your hypothesis is acceptable or it has to be rejected. If you were able to calculate the velocity and your graph looked like an object traveling at a constant velocity, then you can probably accept your hypothesis, which everybody, spoiler alert, had better see, okay, on this. It should all look the same. Then you can accept it, okay, based on that. Just explain a little bit about that. Okay, my graph looked like this, and the calculations show this, therefore, okay, accept or reject. And then, identify any sources of error and suggest improvements to the lab. I'm looking for 2. Okay, so I'm going to want 2 sources of error and ways to fix them. Okay, so 2 sources of error plus ways to repair them, okay, or better ways to do the procedure that would eliminate those sources of error. They can be a bit like, the improvements you suggest don't necessarily have to be things we could do. Okay, you could say something that's, you know, maybe beyond the technology that we have here to do. Okay, everybody all right with that? Okay. Any questions there? All right, I think I made the due date for this on Monday. All right. So you got lots of time to get it done. And obviously you'll have all of class today to work on it as well, but it'll take us a little while because it'll be the first time that you use all this new software. Right? So the instructions for using this software are in Google Classroom. They're in the class materials here. Okay? It's in other important documents, I believe is where I put it. And it's got Smart Cart instructions here. Okay? So I'm just going to open that up and kind of walk you through from that document so that you know what you're doing. Okay? All right, so you're going to open the Sparkvue app, okay, and you're going to press Sensor Data. Okay? After a short time, smart carts that are near you will appear under the Select a Wireless Device to Connect. Okay, so this is what the readout, what your screen will look like. Okay, you're just going to click on Sensor Data. Okay, and then you'll be looking for the cart you have in your hand. You can see that they have numbers here beside them. Okay, those correspond to this number right here. So there's a little silver block on both the red and blue carts. That's the number. So you have to look at which cart you have. If you connect to a cart you don't have, it's really going to mess up the people trying to work with that cart because it'll only talk to one phone. Okay? It will not talk to multiple phones. Okay? So you have to make sure you're actually using the cart number you have, or it's really, really cumbersome. Okay? So just look for that number, okay, look at your cart, and then connect to that cart. Okay? When you do that, okay, then you'll tell it what measurements you want it to take. We always uncheck some of these boxes, but inevitably it still sends us all the data. There's some sort of glitch unless they fix the app over the summer. Okay, so what you will do is just click on position because that's all we need. Okay, so you'll click on position or unclick everything else. Okay, because we don't want the acceleration in the X, Y, and Z axis. We don't want force. We don't want any of that other stuff. Just the position is all we're looking for. So you'd select that box and only that box. Okay, and you'd ask it to show you the graph on your phone. Okay. When you get all of that selected, you'll see this. When you see this, it's ready for you to start your experiment. Okay, so that's when you'll give the person the 3, 2, 1, go. When you say go, press the little green start button, and it'll start graphing the data right on your screen. We're not going to use that graph, it's just showing you what it's recording. Okay, so you have a pretty good idea of what that should look like, okay, for an object traveling at a constant velocity. Okay. When that first trial is done, okay, your cart reaches the end of the track or whatever, just press that button again. It'll be red. Press it again, and it'll stop. Then you can set up for the second trial. Exactly the same procedure. This light will turn green again. Press it again. It'll do the second trial. It'll record both side by side. Okay? Everybody with me there? Once that's done, then you can share your data with everybody. So this is what it looks like while it's running. Okay? And then after that, you will want to share your data. Okay? So you'll click this button up here. Okay? That's the share button. It'll ask you, okay, you want to share the data, and then you'll want to do that through Drive. Okay, so you also need to have the Google Drive app on your phone, okay, connected to your school account. Okay, it'll save it in your Drive, and then from Drive you can share it with your group mates. Okay, from the Drive app you can then share that file. All right, so it'll be called exporteddata.csv. You can change that obviously to whatever you want, like position time graph or something like that. Okay, that's more meaningful. Okay, you can select what folder you want to put it in. That's entirely up to you. Okay, and then like I say, you share it with the rest of your group. Okay, if you don't remember all that, don't worry. You have access to this document and me. Okay, and I will come around and help you if you're getting stuck in it. Right, so let's try and keep the groups small. We've got 8 tracks and 8 carts. Okay, so if we're in groups of like 4 or less, that would be ideal. Okay, so we can keep the groups small and eliminate being too close to one another. Now, in terms of where are we going to do this lab, because again, we want to try and be as distant as possible here. Obviously, you won't be able to distance from your group members as much, so you have to have your masks on while we're doing this. Okay, we'll try and put like maybe one group right here, okay, one group over in the corner there, right? We can have another group right here, okay, and I don't think there's no one in the lab across the hall, so we'll put 5 more groups across the hall in the chem lab. Okay, just make sure you spread yourselves out. Okay, really big. If you end up without a group, okay, just let me know. I'll make sure that I get you in somewhere. Okay. Any other questions on that? Okay, so we'll get all of our data, and then at that point, I'll walk you through how to graph it, get it in Google Sheets, and all of that kind of stuff. Okay? All right. Okay, if you open the file you were sent through Google Drive, okay, this is what's going to happen. It's a CSV file, which stands for comma separated values. Okay? It doesn't get translated directly into Google Sheets right away. So when you open it, you're going to see a preview like this most likely. Okay? What you need to do from this screen is right here in the center, it gives you options for programs on your machine that can open this file. For you guys, it'll probably only show Google Sheets. Okay? So select Google Sheets, and it'll open it eventually in Google Sheets. Now there's going to be some stuff we're going to need to take out of there because we don't need all of the data that it spits out. Okay? For example, we don't need the date and time. It's completely meaningless for what we're doing. So all I'm going to do is click right here, okay? And I'm just going to delete that column. I don't want it. Okay? Now I'm going to keep the time for my first trial, actually, sorry, for my second trial, because it's got the longer time. Okay, that's the one that I want to use. Okay, so I'm going to keep my time for that trial there, and I'm actually just going to move it over. You guys won't have to do this because your first trial was your biggest one. Okay, so what we want to do first is delete all the stuff we don't need. So I'm going to delete the time for run 2 most likely, because that should have been your faster one. Okay, so I'm going to delete that column. Okay, I'm going to keep obviously the position for time 1, or for run 1, because I do want that. Okay, I don't need the velocity for run 1, so I'm going to delete that. I also don't need the acceleration for run 1, so I'm going to delete that. Okay, I'm going to delete the date and time for run 2, because I don't need it either. I'm going to keep the position for run 2 and delete the other run 2 columns. So what I'll be left with is just time, position, and position. Okay, those are the only 3 columns that I need. Right, and you'll see those columns as well. Okay, just delete everything else and make sure that your time is the first column. That makes Google Sheets set it up as the x-axis. Okay, now the next thing I'm going to do is actually delete this first row, because if I don't delete this row, it's going to mess up Google Sheets. Google Sheets thinks the first row is the label. Okay, so what I'm going to do is I'm just going to go down into this box right here and indicate that this is run 1, just so I keep them straight. And this one is run 2, and then I can delete the first row. Okay. So now I'm ready to build my graph. Right? So what I'm going to do is click and drag and highlight everything. Okay? All of the data that I have left. So the time and the position data for both runs. I'm going to just click, drag, and highlight all of it. Okay? Now I can already see on here that there's probably some data I'm going to want to get rid of. Okay? Like I can see here in run 2, there was a bunch of data where it wasn't moving, then it moved backwards a little bit, it wasn't moving. Okay, so I'll get rid of all of that stuff eventually. For right now, I just want to build the graph. Okay, so I'm going to go to Insert. And I'm going to go down to Chart. Okay, so I'm in the Insert menu, and I'm looking for Chart. When I click on that, Google Sheets tries to predict what type of chart I want. And for once, it actually picked the right kind. Okay, it picked an XY scatter. If it doesn't pick that for you, you go here to Chart Type, and you simply look for, okay, it'll be down here, Scatter. Okay, if it didn't pick that for you. Now here you can see that I've got all this data here that I'll have to get rid of where my cart wasn't moving, but I'll do that later. Okay, for right now, all I want to do is start getting my graph set up so that it's saying all the right things, like put a meaningful title on it, not time meters run 1, position meters run 2. Okay, that's a pretty meaningless title. Okay, so I'm just going to change that right in here. So I've gone to customize, and I'm going to change my title text to position versus time graph. Okay, something like that. That's kind of a more meaningful title. Alright, so you can change the fonts and do whatever else you want to do to personalize it for yourself. I'm not going to do that. Okay, the next thing I need to customize is my series. Actually, sorry, I want to go over here to back up here to chart axis and titles. I've done the title, but now I want to do the vertical axis, because you can see it did not label my y-axis, and my y-axis needs a label. Okay, so I'm just going to go to that, and I'm going to say, what's on my y-axis? What's on the y-axis, guys? On a position versus time graph, what goes on the y-axis? Ooh, really? Position goes on the y-axis, guys. Okay? Time's on the x, position going on the y. Okay? Position in meters. Right? There you can see it puts it on there, right? So now I've got a properly formatted graph. Okay? Now I'm going to scroll further down here. Okay? It says series. Okay? And I want everything I do to apply to both. Okay? So I'm going to leave that checked. Okay? I can make those points, those dots, smaller. I often do because I find the 7 point is really, really obnoxious. So I make them a little bit smaller. And you can make them whatever shape you want. You can make them triangles or circles or squares or whatever. Okay? The next thing I want is a trend line. Okay, so down here, this checkbox will make a trend line for both data sets. So I click on that, and now it's drawn a best fit line for both. This best fit line for my red data will change when I eliminate all these little parts here that I need to get rid of. Okay. All right, so now that I've got that, the next thing I want to do is some information about my trend line. Right now, the label for my trend line is nothing. I want it to spit out the equation. So I click on this box, and it says use equation here. If I click on that, it puts in y equals m times x plus b. Okay, so for mine, y equals 0.265 times x plus 0.189. Right, that's my equation for that line. Right, so it has already spit it out. That's what you'll need to do the analysis question. Okay, so now that I've got that, okay, I'm going to leave the legend where it is. You can do all kinds of other things if you want to, but this is really what you need. Okay, now that I've got that graph and I can see that there's some points I need to get rid of, and you'll have some that you need to get rid of as well, okay, I'm just going to move the graph out of the way, and I'm going to eliminate some of these points. So here's how I do that. I know that this is that spot where it appears like it's not moving. Okay, so I'm just going to scroll down to here, and I'm going to highlight all of those, and I'm going to get rid of them all at the same time. Okay, and I'm going to do that, okay, by deleting, okay, those cells, and I'm going to shift them up. What that means is it's going to pull all the data below what I'm deleting up to 0. That way the line doesn't start out in the middle of the graph. Okay, which is good. I don't want it to do that. Okay, so I'm going to shift them up. Okay, and now you can see my line is shifted. All those points are gone. Okay, and now it looks like it should. Run 2 is faster than run 1. I've got equations for both. Okay, now I can put my data and my graph into my lab report. Okay, here's how I do that. So I'm going to open up the lab report. Okay, so here in my data, it says insert data charts and graphs here. Right, so all I'm going to do is go back. Let me copy from one user to another. Okay, I'm gonna first copy my chart over, because I wanna, this is my data. Okay, so I'm just gonna do that, okay, copy it over, so I just want Control C, and I'm gonna bring it into here. Alright. So now my data chart is in there, okay, and then I'm gonna do the same thing with my graph. Okay, so I go back to that file, okay, I highlight my graph first, I get out of the data there, so it's not highlighted anymore, okay, and I'm going to, on the three dots here, copy my chart, bring it over to that file and paste it. Try that again. There we go. Okay, so now my chart is in. Now I've got everything I need to do the analysis. Okay, so that's how you do the graph, that's how you get it inserted into your lab report. Okay, if you're having trouble with that or you got some questions, let me know and I'll come around and help.